Alrighty. So here we go. Now the first thing that I'm going to do here is I'm going to actually draw out some lines. Okay? These lines here are going to dictate where I put my floor, basically my floor plan. Okay? So think of it this way. I'm going to think of a floor plan. Here, let me actually title this correctly. 2-point perspective. Floor plan and extrude. All right, so here we go. I'm going to draw this out from point to point. I'm actually going to draw 2 on each side. All right. Erase some of those. Now, I've just created a basic floor plan. Okay. Now, as you start to design more, you'll start to understand that this floor plan here is just very, very arbitrary. But right now, we're just going to be practicing the rules here, and then we'll get into design later. Okay, this is called a floor plan, or people also like to call it the footprint because it is what is the shape of the object as it touches the ground. Okay, so right here is we have our floor plan slash footprint. Okay, now the interesting enough is as we add more of these lines here, we have the ability to continually create different floor plans as we go. Okay, so that's also something that we can definitely sort of think about. Now, we've just created our floor plan slash footprint. Now, let's extrude. Okay, so the number one thing that we're going to do is we're going to take the middle or the point that is closest to us, and we're going to draw a vertical line. Okay, that vertical line now is allowing us to know where that edge is. Okay, that is the edge. So from here, the extruding method is we're going to now draw back onto the horizon line to the vanishing point. We're going to have these other 2 points here and here also get extruded upwards, just to the point of where they're touching that line. All right. Now, let's go ahead and fill in that box completely. All right. So now we have a 2-point perspective box. We're able to see one side here. We're able to see another side over here. And that's very cool because it gives us a very good idea of what volumes and shapes we're looking at. It's very, very nice. Now let's go ahead and also extrude from this box back here, from this floor print. So we're going to start from the point closest to us. Let's also go ahead and mark the other edges as well. I'm going to make this box a little bit taller, so I'm not going to follow this exact line. I'm going to draw this one up, and it's a different height now. So obviously I'm not going to do this and connect it like that. That's completely wrong. What I am going to do is we have to follow the same steps. Take that edge, take it to the vanishing point. Take that edge, take it to the vanishing point. Take the other points of your floor plan slash footprint. Let's go ahead and draw those up. Let's solidify the box. Now, here's a little bit of an interesting one. All right, here's a cube. Let's go ahead and try to do a circle. Or, not a sphere, but this is going to be a cylinder. This is a cube. And here we're going to try to do a cylinder. So first thing is first is, before we get into doing a cylinder, is how do we draw a circle? Well, we have to remember these general rules of how to make a circle, which is we're going to dissect this line into two-thirds, into three equal parts. You have a point here, the edge, 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 and edge, two-thirds in, two-thirds in, two-thirds in, two-thirds. And we're just basically going to connect the dots. Okay, now it's a very rough and rudimentary circle, but that's how we basically get that shape. Okay, so let's see if we can translate that into here. One, okay. Now here we go, guys. So I'm drawing across. From this point to the middle through should give us about the halfway mark. Okay, same thing as well over here, because this middle shows us that it's exactly half. This is also half. So drawing that X across here basically gave us these. Now I know that in the middle, if I cross from the vanishing point through the middle of the box, is going to dissect it directly in half. So let's go ahead and mark down the edges. Edge to edge to edge to edge. Now we have about a two-thirds, a two-thirds, a two-thirds, and a two-thirds. Let's go ahead and mark those as well. And now here's a little bit of the challenge, is trying to create an ellipse that basically touches these markings in the proper way. Okay. Now I definitely do not have the finesse of that, but at least we're starting to get a good understanding of this shape. And so just like if you were going to do this with freehand, is I used a layer to basically give it a little bit more understanding of its volume and form. And then let's go ahead and paint it in a little bit more nicely. Okay. Now, just as I did it from the edge right in the middle, as you can see in a circle, there is no middle edge. So we're just going to have to use the basic outer edges. Okay. Now we're going to do the similar thing up at the top as well. And this is basically to give us the understanding of our box. So I'm going to redraw this box way up at the top. Oops. We have our box inside. Now we can create our other vanishing point here. Cut these apart into 2/3. Let's go ahead and mark some of these regions. And now we can basically start to create our box, or excuse me, our cylinder by creating the top edge here. Okay, so now as we're starting to stroke this a little bit more to show its edges and shape, you could see now the slower process of trying to create what we see as a cylinder and actually duplicate it properly into perspective. So even in here we have to create the floor plan. We had to make the circle, and now we could basically do the extruding process, which is drawing the shape up from the ground. Okay, so here we go. This is going to be a very, very simple exercise for all of us to do. We first had to make the floor plan, which is the box, and we can draw inside of that box to be able to create a better sense of perspective for the cylinder. Okay, so one thing that we want to start to practice here is just the understanding of how to create a perfect square in perspective. Creating a perfect square in perspective is actually very, very important because it allows you to understand what are the equal lengths of a square. So we're going to go ahead and start doing that really quickly right now. And first, we're going to start off with the basic rules of what we've understood so far. The two-point perspective square in space is going to be a pretty crucial point for understanding anything that has to do with measurements in space, because it allows us to really quickly understand those types of rules. So we're going to start off by creating our horizon line. Okay, we have horizon line over here, and we're doing two-point perspective, so we're going to basically be doing something that's called finding your center vanishing point. Now the center vanishing point is quite in particular because we have to now create exact 45-degree angles from our initial vanishing points, 1 and 2. So what I'm going to do is I'm just going to draw a straight line down. This is going to allow us to basically see what our 45-degree angles are doing. So we have over here, and we want to do a 45-degree basic line from here to draw it down. Now if I put a perfect square here using my Photoshop techniques, we're able to see that there's a perfect 45-degree angle happening right there. Okay, and we'll basically be able to do the same thing as we keep on kind of adding in these lines. So let me do that one more time. Just going to go ahead and draw a 45-degree line all the way down there. Now for the other side, I'm going to be basically doing the same thing. And so here we have our meeting point. This center point is going to give us the of how to find the center vanishing point. So I'm going to draw this line straight up, and I'm going to find where it meets here, and I'm going to call that, center vanishing point. This is going to be a crucial part of understanding how to create that square. Now from here, let's go ahead and use a blue line to start creating our perspective box. So I'm going to start off over here. I'm going to draw out a perspective line and another one over here. as we start to develop some of these ideals, or we're starting to get a good grasp of these points, I'll go ahead and draw another line out here. Okay. So the blue lines are our perspective lines. Don't mix up the red lines and the blue lines, as the red are just indicators of finding the 45-degree angles and our center vanishing point. The blue lines are actually our perspective lines. So here's the interesting part of trying to find the exact ratio for a square. Is this center vanishing point and this point closest to the viewer, we're going to draw a straight line. Now where this point meets this secondary line on the vanishing point is our second point on the further on the perspective line that's further away from us. So we now connect this line and this point together to give us the further vanishing point, or excuse me, the furthest perspective line that is going to now create our box. So now we have these two lines creating 4 points in space that now represent exact equal sizing. Okay, now that's going to be very important for us to kind of realize here. Now this is a perfect square on the ground. We're able to dissect this square in half to basically find our half point. Now this half point is going to allow us to cut this box apart. It's going to allow us to find exactly the halfway points between all of these elements here. And so this is how we're creating a perfectly equal length square in perspective for this purpose. Okay, now this is going to allow us to figure out how to create a perfect square in space, to not only know the square and sizing, but also it's going to allow us to find how to create a circle within the space. So how do we create a circle? Well, let's go ahead and start with a perfect square and basically start building on top of that. Alright, so now back to squares, but now squares with volume equals cubes. So now we're going to talk about cubes really quickly within the 3-point perspective space. And the 3-point perspective space, the only thing that's different about this is now including the idea of measurements. Okay? So the idea of measurements is going to allow us now to start creating the understanding of the vertical space in order to also create the volumetric form that a cube would have in perspective. So let's go ahead and start with that. The first thing we're going to do is start putting some measurement lines. This is a 100% vertical, and I'm also going to draw a 100% horizontal based off of this point that is closest to the viewer. Okay, so this is the point of the box on the ground. You see that point, and this is us with the camera, so this is the closest point to the viewer, and we're going to use that as our measuring tool. Now the first thing that we can actually do is figure out where this center point actually goes to meet this line. Okay, now I'm going to stroke it a couple times because I do not have a ruler right here, and that's going to allow us to understand some of this complexity. Now if I had a ruler, I could draw this line, I could measure it, and I could see exactly how large or how small it is within space. So this is pretty much some of the measuring that we're doing. Okay. Now interestingly enough, this line that I just drew is the exact same length. So I'm going to go ahead and turn this over onto its side and basically draw it in a way where it's my measuring tool for this vertical up top. Okay, so this line here and the line up at the top are all lines that are going to be representing the same distance. Okay, the same distance. So let me draw that up a little higher. Okay, so from this distance here to this distance here should all be exactly the same. Okay, so that's how we're going to get our essentially our box right now. Now, one interesting thing enough here is that as we start to draw this line up, we start to understand some of the volumetric forms that we're looking at. Now, one of the things that we're going to be able to do here is essentially get an understanding of our line weight and our front face of this box. Now, the front face of this box is very, very interesting because we need to get this distance here to be represented vertically. Okay, we want to get that represented vertically. Okay, so now once we have our lines, let's go ahead and draw this out. I'm going to take this down to the vanishing point to find our box. I'm going to draw this line all the way up, which is the middle point where it meets there. We're also going to draw this line up, all the way up. Now we know if we break this box down with an X, we'll know exactly if we've hit the middle point, which we kind of did right there. And we know that this is the front face facing us with the exact same dimensions as what's happening behind it. Now also understand that this is a very, very extreme push of 3-point perspective or 2-point perspective, but we're just doing volumetric forms. So let me actually readjust this really quickly here. So we're trying to get a cube in the 2-point perspective realm. We'll do measurements here just to make sure we're somewhat accurate. Okay, let me get this a little bit better. And now we start to see that the box on the ground is now evident on both sides, and we're able to now create a vanishing point that helps us to find the center line of the square sitting on the ground by drawing out our 45-degree angles that we did previously. And now we're able to extract the vertical sides of the box to create a cube. Just going to use this red line to basically outline this cube in its entirety. Within space. So the general rules of creating a perfect box in space, we basically just need to find our center vanishing point, and from there we're able to extract each side vertically to create a perfect cube. So there you go, and this is our basic starting points for understanding equally sized blocks or buildings, or even creating spheres or cylinders within our perspective environment or our perspective space to create whatever designs you're trying to communicate. So perspective becomes a very valuable tool and something to really practice, and these are the guiding steps to kind of get there. Now, we've just done cubes and we've done cylinders. Now it's going to be really easy to do a couple of other things. Let's go ahead and do one more, which is going to be a basic pyramid shape. Now the pyramid shape starts off from a basic square, right? You have 4 corners, 4 edges that meet to the top. The side profile of it is basically triangular. If we know what a square looks like, we can understand that this is exactly half, right? It's half. 1/2, 1/2, and these are all quarters. Okay, so if we kind of know that, we'll see how this can basically translate into perspective here. So we're going to do 2-point. We're going to have vanishing point, vanishing point. Let's go ahead and draw this really, really kind of far down so we can see kind of more of what it looks like from the top view. Okay. So we just cut that out. We've dissected this into 4 equal parts. Okay. Let's go ahead. We know that's the middle. I'm going to draw that middle point up to whatever height you really want to create. Now one of the tricks is that we can actually dictate what that 45-degree angle is, because this is completely vertical and this is completely horizontal. And we cut that angle in half to basically create our 45-degree angle. That 45-degree angle, to just break it down one more time. Okay. Full is 90 degrees. We divide that in two and you get 45 degrees. So from here, that's your roughly 45-degree angles. It's not exact, but again, this is a simplified drawing of what we're trying to create. Okay, so here we go, guys. It's a very, very simple application of trying to get this pyramid to work within perspective. Okay, oops. So there we have it, guys. We have a couple of two-point perspective applications here. We also have some breakdown of your environment, of how to break down an environment, because now you're using these two-point perspective rules to give you some shapes, how to draw these shapes within perspective properly. All right. Now, one of the cool things is, check this out, is let's go ahead and look at some other samples. So right over here, guys, you can start to see that as we draw the angularity of our guidelines more severe, okay, you see how much closer these vanishing points are? The closer the vanishing points are, the more skewed this footprint floor plan is going to be. You can actually see how skewed that is. Versus over here, it seems a little bit more flatter. Here, it's very, very, very flat. Okay, so you can see the pulling apart these vanishing points as well as adjusting the angularity of these lines will give you these different types of viewpoints. Now, for this one, this definitely looks like we're looking at it from another tall building, perhaps, or from an elevated point of view. This one here gives us a very extreme overhead shot. Perhaps we're looking at it from a helicopter or looking from a high-rise, looking at a smaller building. And this one over here at the bottom, we're essentially being able to use these, the bottom shot, to have more of a relative angle and understanding of these shapes. Now, this probably looks like we're looking from a similar height building within the building, maybe on the 5th floor, looking straight out and seeing another building at around the same height. So that gives us a good understanding of how to use two-point. Okay, now we look at height over here, we look at width, and then now the depth of it, which is also, if you kind of depending on which angle you look at it, is also the width, but it gives you that sense of depth and sense of space. All right, so this becomes a very, very important tool to use. Here's another quick example of two-point perspective of just something from a city. Now, the vanishing points, if you look at it, look at 1, 2. But notice how long and flat this guideline is and how severely kind of angular the other guideline is. This allows the viewer to see something that looks a little bit more natural to what we see in real life. It is ideal to kind of see everything with equal space, okay? But what happens in design, and for concept art especially, is we don't really want to use this that much. The reason why is because each side of this thing is calling for equal amount of attention. What we want to do to make things a little bit more interesting is actually go into this realm a little bit more. Longer and then more angular. Okay? Longer and flat, angular and severe. So when we look at this vanishing point guideline, this is more angular, okay, and extreme. This is flatter, okay, and we'll just call it flat. This allows us to see a lot more of one side and a little bit less of the other side, creating a difference in shapes and a difference in read. So this is a very, very important understanding, okay? Because we all know how to do two-point perspective, but the real key is how do we use it properly, okay? So while we are understanding all of these bits of information, I always want to have you guys not just understand the rules here, okay, but how does it actually apply to the actual concept art, because it's not always the same. Let's really quickly look at a bit of photo. Okay, now this photo over here, just pulled from the internet, is a very, very, very good example, okay, of some very, very good two-point perspective. Let me also grab another really quick example. Here we go. So for these two city photos, really quickly, what I'm doing right now is I'm going to actually extend out the canvas a little bit and try to find the actual vanishing points. Now the cool thing is that you can practice this with any bit of photo. We have the horizon line way back here. The reason why I'm not drawing it exactly on the top is because I see that there are hills, some trees, and things like that that are growing on the horizon line. So I'm going to actually drop it down just a little bit more. So now it looks like right now, what's actually cool is that we can use the streets as ways to find, oops, that's not even close at all, to find the perspective angularity. Okay, well, that's really interesting. I think this is like it has a little bit of a skewed lens because it's definitely not straight. But I'll do my best for this example. Yeah, you can definitely see the curvature there. So as we're doing this exercise, what's going to be important is that we just try to figure out the base shape of some of these objects in here. Okay. Now the base shape is basically right there. We can see the two-point perspective, a little bit flatter, a little bit more extreme on this side. And on this one as well, there is this might be a little bit harder to kind of identify, but we have a very key footprint right here. This footprint is going to allow us to basically follow these guidelines that we know and understand and use this as a starting point to find our perspective guidelines. Okay. Now the only thing for me is because I don't have a ruler is that I have to kind of guess the angularity. It's just going to take me a little bit more time, but it definitely does work because we know the rules. All right. Now there is our vanishing point number 1, our horizon line. I'm actually going to have to extrude out this line a little bit more. Okay, I gotta take it off of the page a little bit more. All right, let's go a little bit further. Now, super important to try to get the accuracy right. Okay, we'll call that just about enough. So we kind of see here that we have our 2-point perspective angles here. Now this is very flat and this is very, very extreme. So we've really seen a couple of examples right off of the bat that show us the kind of differences within just some of these photos and how to find your perspective within these photos here. Okay, this is going to be such a good exercise for you to practice because 2-point perspective essentially has endless amounts of different viewpoints that you can create, from looking up at things, to seeing the true viewpoint that you want to capture a scene, to looking down, looking across the city, looking at objects up close. All of these different types of viewpoints that you want to try to capture can realistically be done within just 2-point perspective. Now, 2-point is where I actually use those methods the most for actual production work and personal work. Is I realistically only use 2-point perspective. Maybe I'll get into 3-point perspective once in a while, but essentially I use 2-point perspective. All right, so this is our general breakdown for 2-point perspective, from understanding our base rules to understanding why we want to use different angles and extreme versus flat for our guidelines, and how to actually break down a photo. Alrighty, so now let's talk about 3-point perspective. Alright guys, so talking about 3-point perspective now. Let's go ahead and cross off 2-point off of the list. Now let's talk about 3-point. Now, 3-point perspective is by far the most challenging of the three. It actually creates such a lot of drama and extreme point of view angles that look so cool, that look really, really nice, but also create that much more work for you as the artist. Now, what I'm going to suggest is that you learn 3-point perspective to really grasp the complete understanding of all of the set of rules. And we will go through a series of practices and exercises to be able to execute and finalize these. But the thing is that, I want you guys to really have that solid foundation that we were just discussing regarding all of that. And, the better that we can create this foundation for us, the better that we'll have chances of becoming a very, very solid artist and designer. That can be especially important for games and film. Okay, so let's talk about 3-point perspective. Now, 3-point perspective, you guessed it, has 3 points. The 3 points relating to 2 on the horizon line, okay, and 1 either way up in the sky or way inside of the ground. You're actually going to need a lot of paper or a lot of space to create these 3 points. Okay. Now, really quickly, let's go ahead and talk about this. So I'm going to go ahead and open up a new page. All right. Now I'm not going to turn this horizontal because I need the extra room for the third vanishing point. So first, let's go ahead and do 3-point perspective. Okay. And this is extreme angles. So the first thing that we're going to do is we're going to start off the same way as we always do. We're going to create the horizon line. We're going to have vanishing point 1. We're going to have vanishing point 2. And for this exercise, we're going to go way down here and go to vanishing point 3. Okay, that third vanishing point is down way below, and we need it to actually create the right amount of angularity and convergence as possible. Now, when you guys do your assignment, definitely play around with placement of this third vanishing point. In fact, with all vanishing points to see what kind of differences you guys will get. So here we go. Let's go ahead and start with the floor plan. Okay, we're going to go ahead and draw all of our guidelines, and let's go in and extrude the shape. And lastly, we're going to just do some detailing on top just to get a sense of what kind of thing that we're drawing, okay? I'll move this down here. Let's fill that up again so I have more room to actually play around. All right. So here we go. Let's go ahead and now I'm going to go ahead and draw my first lines to create my floor plan here. Actually, let me start over here. All right, let's go like this. Okay, so created the floor plan. Now what we're going to do is draw all of these lines from the third vanishing point to pass through these different edges. Oops, it's pretty off. Getting better at it. All right. Now, cool. We have the 4 edges, the 4 corners, going all the way down to the third vanishing point after we created the floor plan and we just created our guidelines. Now we're basically going to go into extruding the shape. Now we're going to draw up. Here's the height of that edge. Well, I'm going to make it a little bit shorter just for the sake of the demo. So I'm going to make sure that passes all the way through, hits that edge. This one's going to go all the way down back to there. Now we have our box. I'm actually going to draw the box in a slightly different color so that we can see what I'm drawing. Okay, so we can see the shape actually goes down into space. We don't see the top, we don't necessarily see the bottom, but we can see the volumetric form of this cube in space converging towards the bottom third point. Okay, let's go ahead and do another one really quickly as well. Horizon line. label all of these. VP1, VP2, VP3. Let's go ahead and start with our floor plan, creating our box or our cube or whatever shape that we want, our cylinder, or excuse me, a rectangle. Let's go ahead and start extruding these lines down to the vanishing point. I'm going to create the edge in which I need to make the edge of my actual box. Okay. I'm going to draw that down a little bit as well so you can kind of see the difference. And then now we're going to extrude the actual shape. Okay. Now, a couple of key things that we can definitely do are, let's talk about adding some details so that we can actually see what we're drawing now. And you can kind of see here is if we're doing this to our building, you can see how it starts to add in a lot of quick information and details so that it looks like an actual building. Right? We have a little door down here.